A very important application of definite integrals properties. Integral minus 4 to minus 5 e to the power of x plus 5 the whole square dx plus 3 times integral 1 by 3 to 2 by 3 e to the power of 9 times x minus 2 by 3 whole square dx, right? There are two integrals taking part in this. So let's evaluate the integrals separately. Let's call I1 as the integral from minus 4 to minus 5 e to the power of x plus 5 whole square dx. Now in this problem we use a very important property of definite integral, that is integral a to b f of x dx. Every integral can be mapped to an integral between 0 to 1 as integral a to b f of x dx equal to b minus a times integral 0 to 1 f of b minus a times x plus a dx. Right, a very important property of definite integrals. Now when we use that property here, this can be now become minus 5 minus of minus 4, that is plus 4 times integral 0 to 1 e to the power of minus 5 minus of minus 4 plus 4 times x minus 4 plus 5 whole square dx. Now this is same as minus of integral 0 to 1 e to the power of x minus 1 the whole square dx. Let's call this as equation 1. Now the advantage for here is the different integrals minus 4 to minus 5 has been brought to 0 to 1. Now let us see what was the advantage in converting the integral to 0 to 1. What happens if we apply the same result on the second integral also? Now what is I2 for us? The second part of the integral, that is 1 by 3 to 2 by 3 e to the power of 9 times x minus 2 by 3 the whole square dx. Now again when we apply the same result on this value becomes 2 by 3 minus 1 by 3 times integral 0 to 1 e to the power of 9 times 2 by 3 minus 1 by 3 times x plus 1 by 3 minus 2 by 3, x replaced with b minus a times x plus a whole square dx, which is simply 1 by 3 times integral 0 to 1. Yes, here also it would be e to the power of x minus 1 whole square dx. This is equation 2. Now look at 1 and 2. You understood why we converted both the limits at different places from minus 4 to minus 5 and 1 by 3 to 2 by 3. What do you observe? The integral function on both of them is now same. E to the power of x minus 1 whole square dx is present in both of them. So what do we observe from equation 1 and equation 2? Yes, we get I2 value as minus 1 by 3 times I1, or can we rewrite this as I1 plus 3 times I2 equal to 0. But what is I1 for us? Yes, the value of I1 is nothing but integral minus 4 to minus 5 e to the power of x plus 5 the whole square dx plus 3 times. What is I2? What is I2 then? Integral 1 by 3 to 2 by 3 e to the power of 9 times x minus 2 by 3 the whole square dx, and the value is coming to be 0. So what is the value of this integral? That's what is the required value to be evaluated. So the value is 0, right? And beautiful application of change of integral limits. Any integral from a to b can be changed to an integral of 0 to 1. Try to remember this result. This is a very important property in definite integrals.